Alright, so this is my seventh example on improper integrals, and this is improper integrals with infinite discontinuities. Alright, so f is continuous on the interval ab, and notice we're not including b, but it has an infinite discontinuity at b. Then the integral a to b f of x dx, what we're doing here is it's discontinuous here at b, so what we're doing is we're replacing b with some other letter, and then we're taking the limit as b goes as this whatever we replaced it with, in this case c, as c goes to b from the left. Okay, now this is the upper limit is discontinuous, so when we take the limit we approach that from the left. Well, in this problem it's discontinuous at a, which is the lower limit. If it's discontinuous at the lower limit, then we're going to come into that value from the right. Alright, so if it's the upper limit, we come in from the left. If it's the lower limit, we come in from the right. And then if f is continuous on AB, okay, and this means it's continuous at A and at B, but we have some number in this interval, say C, where f has an infinite discontinuity, then what we'll do is we'll split it at that discontinuity. Okay, we'll go the integral a to c plus c to b. Alright, so let's take a look at an example. So I've got the integral -1 to 2 of 1 over x cubed. Alright, so looking at this, we can see that this thing is continuous everywhere except for where? At 0. Okay, so we have an infinite discontinuity at 0. So the first thing we're going to do is we're going to split this thing up. So we're going to go from -1 to 0. That's where it's discontinuous. Now this 1 over x cubed, I'm going to go ahead and just write it as x to the -3, so we can integrate it. Alright, dx plus, and then 0 to -1, I'm sorry, 0 to 2. So I go from the lower limit to where it's discontinuous 0, and then from 0 to the upper limit 2. And that's x to the -3 dx. Alright, now we're going to take the limit. So this is going to be the limit, and I'm going to use b as b goes to 0. Okay, and since it's the upper limit, I'm going to take the limit as 0 goes, as we approach 0 from which side? The left. Okay, and that's of -1. Okay, and then the 0 gets replaced with b, and then that's x to the -3 dx plus the limit as b goes to 0. Now here it's discontinuous at the lower limit, so I'm going to come into 0 from the right. Okay, and then the 0 gets replaced with b, and we're going to 2 x to the -3 dx. Alright, so now I'm ready to integrate this thing. So this is going to be the limit as b goes to 0 from the left. Okay, so I add 1, so that's going to be x to the -2 times the reciprocal. That's -1/2, and I'm going from -1 to b plus the limit as b goes to 0 from the right, and then this will be the same integral. That's -1/2 x to the -2, and I'm going from b to 2. Alright, so let's do this part. So that's going to be the limit as b goes to 0 from the left, and that's going to be -1/2 b to the -2 minus -1/2 -1 to the -2. I need one more parenthesis. Alright, so now this is going to give us the limit as b goes to 0 from the right, and then I'm going to do the same thing here. That's going to be negative 1/2, and then I plug the 2 in, so that's going to be 2 to the negative 2, and minus negative 1/2, and then I plug the b in, b to the negative 2. Okay. Alright, now let's just kind of rewrite this a little bit and clean it up. Okay, so this is going to be the limit as b goes to 0 from the left of negative 1 over 2b squared. Okay, the b is going to come down there with the 2, and then this is going to be plus, and then remember this negative 1 to the negative 2, that's the same thing as 1 over negative 1 squared, which is 1 over 1, which equals 1. So this is just 1 right here, and so this is going to be plus, well, let me get back to the right colors. So that's going to be plus 1/2. Let me get this out of the way. Alright, and then this is going to be plus the limit as b goes to 0 from the right. Alright, so this, okay, so let's just take this part right here. That's going to be 2 to the negative 2, which is 1 over 2 squared, which is 1/4. And so this is just 1/4. So let's get rid of this. So this is going to leave me with minus 1/8 when I multiply them. And then the minus and the minus, that's plus 1 over 2, move the b down to the denominator, b squared. Alright, so now let's look at this. Now, if we take the limit as b approaches 0 from the left, so if you look at this, it's we're plugging in numbers like negative 0.01, negative 0.0001, so you can see the denominator's getting really small and the numerator staying at 1. So that means this term right here is going to infinity. Well, we have the negative sign in front of it, so that means it would be going to negative infinity. So this is not converging to any number. So if any one of them, whether it's this one and this one, or just this one or just this one, if they're not converging to a number, then what we say is that this diverges. Okay. And you might work some where both of them approach a number and you actually get an answer, a number as an answer. They may both converge to something, but in this case, well, this one didn't, so we don't really need to do anything here. And of course, you can see also this term here goes to infinity. It diverges also, but we don't even need to check it because this one diverges, and if one of them does, then that means the whole thing is going to diverge. Alright, so that's the end of this video. I hope it helped. Hope you'll check out my other videos, and if you like them, you can subscribe. Alright, thanks.